DLCO is your diffusion test studies. These are looking for how well oxygen goes across the AC membrane and into the bloodstream. People who have interstitial lung disease can have a reduced DLCO. People who have obstructive lung disease who are air trapping significantly can also have a reduction in DLCO. For the one who has interstitial lung disease, purely it's that it's a widening between the alveoli and the bloodstream because the interstitium is inflamed and widened. Okay, with the COPDer who's significantly air trapping, it's nothing more than the fact that there's no fresh gas going into those areas, that they're air trapping really bad. So therefore, those areas are not participating in gas exchange. And if they're not participating in gas exchange, you're going to have a reduction in DLCO. So just seeing a reduction in DLCO does not just mean that it's a problem between the alveoli and the bloodstream. It can be that there is a problem getting the fresh gas to the alveoli in the first place. This is an example of where you're going to see a combined problem. COPDers who air trap enough can actually have both an obstructive lung disease and a restrictive. Think about it. If you're air trapping and your diaphragm is being flattened and your whole chest is being filled with air that you can't get out, it only stands to reason that you're not going to get as much in. So if you think about the process of COPD and what's happening, the disease itself can actually cause both an obstructive and a restrictive. Not always. It depends on how bad the air trapping is. You will see that, particularly if you do body plasmography and looking what your RV is. Then if you do the DLCO, you'll see it reduced. Also, people who have a reduced hemoglobin are going to have a reduced DLCO. If they don't have as much to carry, they're not going to carry it. Remember, for DLCO, we do use carbon monoxide, very small amounts. It's not enough to hurt anybody because hemoglobin loves carbon monoxide. So we use it, and then there's a conversion factor that we have to do it's based on the weight and the solubility coefficient, etc., of the gas for oxygen versus carbon monoxide. And when there's a conversion factor we can do to say, well, if this had been oxygen, this is what the value would have been. Okay, interpretation of PFTs. You need to know how to calculate percent predicteds. If a predicted is 2.5 and they actually did 1.6, you divide what they should have done into what they did do, and that gives you a percent of predicted. I look at it the same way as if, I make $800 a week, but I only take home $400. I only take home 50% of my total income. In the case example here, I'm only blowing out 65% of the total that I have in my lungs in 1 second. Okay. How do we consider something to be significant response when we're looking at percent predicteds and FEV1, FVCs? Is if your flows after bronchodilator is increased. Most labs today are even going with 15%. I say 15 to 20, but most labs are going at 15%. Some labs have actually reduced that to 12%. They're saying, look, if we have a 10-12% change, we have something going on. But for the purposes of my test and for the board, stick with 15 to 20%. We already talked about obstructive versus restrictive patterns. In an obstructive pattern, you're going to see an obstruction to flow, not necessarily an obstruction in volume. If they get air trapping bad enough, you will see that, but in its purest sense, it's the flows and they have trouble getting air out. Whereas with the restrictive pattern, it's the volumes and they're having trouble getting air in. Whatever they get in, they get out just fine. Make sure you know this box. Make sure you know it. You need to know it. You need to know it well. Okay? If you know this box, you can figure out anything. I'm going to be showing you an example of that. You will see several questions that say, if your tidal volume is this and your IRV is this, what's your IC? Or if your RV is this and your FRC is this, what's your ERV? If you know this box and you know it well, you can figure out any of those. Okay, so make sure you spend some time here. Alright, so here's an example of knowing this box. In this particular capacity, the total lung capacity is 5 liters. The FRC is 2.5 liters. So what is our IC, our inspiratory capacity? Okay. If your total lung capacity minus FRC equals IC. If you look at the box, it can guide you. You don't have to memorize these. Look at the box. If TLC is over there on the left, and if IC and FRC equal TLC, then if you take TLC minus FRC, it's going to equal IC. Okay? So spend some time here. Get comfortable doing that. Come up with a couple of values and say, well, if my vital capacity is this and my ERV is this, what's my RV? You know, or if, what's my FRC? Or whatever. You know, I'm trying to come up off the top of my head here, but there's a million different ways that you can calculate different tidal volumes or capacities or volumes and try to find an end result. If you know this box, that's really all you need to know, because this box is telling you what things add up to TLC. Vital capacity and RV equal TLC. Inspiratory capacity FRC equal TLC. IRV, VT, ERV, RV equal TLC. Okay. TLC minus RV equals vital capacity. TLC minus IC equals FRC. TLC minus FRC equals IC. There's a gazillion patterns you can do. IC minus IRV equals VT. Use the box, it will guide you. Okay, here's actually I think there's only one more question or slide here, and that is a question you might see of, what if something is wrong? What if, you know, especially when we're dealing with lung volume, sometimes something comes out wrong. Okay? Which of the following values needs to be recalculated? Well, let's look here. Don't get caught up in the FVC, FEV1, your flows, because you really can't recalculate those, except that you could do some percentages and say, well, does the FEV1, FVC, is it really 80%? Is the FEV1 that they actually did versus the predicted 80%? You know, go through that part of it. You can't recalculate the actual measurement, but you could recalculate the percents that they did, or their FEV1 to FVC ratios. In the lung volumes, here we have somebody who has a TLC of 5.0 liters, an FRC of 1.8, an ERV of 1, and an RV of 1. Well, I can tell you without even looking at anything else, the RV is not possible. It can't be right, because the FRC equals 1.8. ERV plus RV equals FRC. If I add ERV and RV, that equals 2. But they're saying my FRC is 1.8. How do I know it's my RV that's off? Because that's usually the one that is off, because it's the most difficult one to obtain. Now here's your box, and I just told you FRC minus ERV equals RV. Okay, so spend some time here, get used to working with the box. It's really important that you know this box. I guarantee you will see it on your board test, on my test, and if you know this box, there's a lot of things they can throw at you that you can figure out relatively easy. That pretty much concludes the review. The test is 35 questions, though I don't typically do comprehensive type questions on my final exams. I have chosen to do that this time just because this is a hybrid class. I want to get a little bit better feeling in your own words of what it is you know. There's just a couple. The rest are multiple choice. Like I said, there are a lot of questions about what is the vital capacity if the TLC is this and the RV is that, etc. So get to know this box. If you have any questions, this get with me before the test. This will be put up early enough so that won't be an issue. Hopefully this course went well. This will be the final audio that you'll have from me on this course before you take your exam in class.